The property of equality for logarithms looks like this. And you may recall it looks a little bit like the property of equality for exponential functions, which looked like this. Remember? Property of equality for exponentials. What we said was, hey, if I have a power and the base, if I have two powers, I should say, and the bases are the same, then their exponents must be equal. So we then said, if we have this here, that this down here must be true as well. Well, it turns out that if I have the log base b of x and it's equal to the log base b of y, in other words, there are two logarithms with the same base, whatever the arguments are, and I'm going to introduce a new term here. This guy is known as the argument of this log, and this guy is the argument of this log. And let's go ahead and write that out so you can actually add it to your notes. We'll use this idea of argument of logs again. And it'd be nice if we were all speaking the same language. Anyways, if you have two logarithms with the same base and they're equal to each other, then their arguments must be equal. In other words, x must equal y. Now, this is awfully abstract when I'm trying to describe to you, so it'd be much better with an example. I mean, something really straightforward and easy would be something like this. What if I said log base 3 of x is equal to log base 3 of 7? Well, that's no challenge at all. What this means is simply that x must equal 7. And again, hopefully that's obvious to you. You know, if I take the 7 and pop it in there in place of x, the two sides look exactly the same. So of course, setting x equal to 7 of course, it must be true that x must equal 7. Now, let's try to look at maybe a fancier example. What if we have something like log base 2 of 2x minus 3, and that's equal to log base 2 of, I don't know, how about 7x plus 4. And I'm going to put parentheses in here. Unfortunately, the textbooks sometimes use parentheses, sometimes they don't. But I'd like to make it really clear that 2x minus 3 is the argument of this log. All of this is the argument of this log. And 7x plus 4, all of this is the argument of this log. So in this case, what we'll say is it must be true that 2x minus 3 is equal to 7x plus 4. And then we do the solving of a simple linear equation. This should end up being something like, we'll get 5x here if we subtract 2x from both sides. We'll get negative 7 over here if we subtract 4 from both sides. And then x must equal negative 7 divided by 5. And although it's kind of tricky, if you were able to take negative 7/5 and plug it into x here and plug it into x here, and if you knew how to use a calculator to take a log base 2 of something, we'd be able to see that this side is equal to this side. So anyways, these are some of the benefits of having property of equality of logs. Is that if we know one side, if we know that there's a log of something and it's equal to the log of something else, and they have the same base, then we can say that the something must equal the something else. That's kind of the cool thing. Now, there can be problems with this concept. If for some reason you solve and you get a value for x, if for some reason it makes this argument negative, well then we have an extraneous solution. You have to throw it away. You might recall extraneous solutions from when we talked about rational expressions. If you had an expression that looked like 1 over x minus 3, and it was equal to 13 over x minus 2. If we ended up solving this guy and x either equaled 2 or 3 as our solution, we'd have to throw that solution away. We called it extraneous. So it turns out the same thing is true with logarithms. With logarithms, for logs, let's see if I can write this. Let's do a fresh new color here. With logs, the argument must be greater. The argument must be greater than 0. Greater 0 or greater. Well, let's take a look. Let's think about this for a sec. Let's see here. Log base 2 of 0 equals what? 2 to what power equals 0? I can't, 2 there's no 2 to no power equals 0. So it's got to be, logs must be, the argument must be greater than 0. Greater than 0. Argument must be greater than 0. And another fancy way to say the argument must be greater than 0, of course, remember, we can easily just say greater than 0. That's a nice way to say it. So anyways, and what that leads to is this. If we have an argument that's greater than 0, let's see, so otherwise we get an extraneous solution. Otherwise, we get an extraneous solution. So when we're doing logs, if we get a solution like, oops, I lost my negative 7/5 here. There we go. If we get a solution like x equals negative 7/5, we should check to see whether the argument is 0 or negative. If it is, then we must throw away the solution. And that is kind of property of equality for logarithms in a nutshell.